Well, hi guys, today we're going to do some basic trigonometry, and hopefully till the end of this video you will gain a knowledge of how to find the trigonometry functions of any angle in a right triangle in a function of its sides. Let's first start with a right triangle, and let's set the sides of this triangle to A, B and C. And now let's set some random angle in this triangle, for example angle theta. We will now try to find the trigonometry functions of sine theta and cosine of theta. So in order to do this, you need to know a few things. First, you need to know how to find the biggest side in the right triangle, and that is hypotenuse. It's really easy if you can notice it right away, but if you can't, there's a little bit of a tip for you. The hypotenuse, or the biggest side of the right triangle, is always located opposite of the right angle of this triangle. So if we have a difficulty finding it, just find the right angle and opposite to it will be hypotenuse. Now, second thing that you need to remember is that hypotenuse will always be located in the denominator of the sine and cosine function. So let's put the C there. First, let's take a look at our angle theta. You can see that there are two sides that make this angle. It's hypotenuse C and the leg of the right triangle B. So the leg that makes our wanted angle theta with the hypotenuse is B in this case, and this will always go into the numerator of the function of cosine. So the easiest way to start with a sine and cosine is to first find a cosine, because remember, the B will be the leg that makes our angle with hypotenuse. Next, let's try the sine of theta. Well, you guessed it, it's the side that doesn't make the angle with hypotenuse, and in this case it's the leg A. So in the sine we will put the leg that does not make our angle with hypotenuse. And this is a really great tip for you guys to remember. Okay, but what about the other functions? The tangent of theta and cotangent of theta. So first let's start with the tangent of theta. The tangent of theta is actually equal to the sine over cosine of theta. And in this case, you don't need to calculate anything. Just look at the numerator of the sine and cosine. Since the numerator of sine is a, that will go into numerator of our tangent function, and the numerator of b of cosine will go down in the denominator of the tangent. And that's all. What about the cotangent? Well, the cotangent is opposite of a tangent, so it's a cosine of theta over sine of theta. That means that is b over a. And in this way, guys, you will be able to find any trigonometry function of any angle inside the right triangle according to its sides. So stop worrying about adjacent or opposite sides. You don't need that. Only thing that you need to do is 1. Locate the hypotenuse or the biggest side of the right triangle. Tip: it is always located opposite of the right angle of the triangle. 2. Put the value of hypotenuse in the denominator of the sine and the cosine function. 3. Put the value of the leg that makes our wanted angle with the hypotenuse inside the numerator of the cosine function. 4. Put the value of the leg that doesn't make our wanted angle with the hypotenuse into the numerator of the sine function. 5. The tangent is equal to the numerator of the sine function over the numerator of the cosine function, and cotangent is only opposite of the tangent. This is all you need to remember. Now, let's try to do a couple of examples just to make sure that we get this right. So in this example we also have a right triangle, but we have a few values of the sides. We will try to find all trigonometry functions of the angle theta. So here it's pretty easy for us to see the biggest side. The biggest side is of course always opposite to the right angle, but here we can also see that it has a value of 5. That is the biggest value in a triangle. So we will immediately put the value of this hypotenuse in the denominator of the sine and the cosine function. Next, for the cosine, we know that we need a leg that makes our angle theta with a cosine, and in this case it's a leg with a value 4, so we will put this into numerator of the cosine. And for the sine we need a leg that doesn't make the angle theta with hypotenuse, and in this case it's a leg with a value of 3, and we will put it into numerator of the sine. So there you go guys, it's easy as that. We have sine of theta, it's 3 over 5, and cosine of theta is 4 over 5. Now let's try for the tangent and cotangent. First, let's see the tangent of theta. Like we said, only thing that we need to do is to put the numerator of the sine inside the numerator of the tangent, and the numerator of the cosine in a denominator of the tangent. So it's 3 over 4. For the cotangent, we will just switch the values of tangent and put it into cotangent, and we will get that the cotangent of theta is 4 over 3. And like that guys, we have all the values of the angle theta of this right triangle. Let's try another example, this time a little bit more difficult. You can see that in this strange figure we have 3 different right triangles. Now let's try to find the specific trigonometry functions this time. For example, sine of alpha, tangent of beta, and cosine of gamma. Let's first try to find the sine of alpha. For this we will need to take a look at this red right triangle with the sides of 15, 9 and 12. Now we can easily spot the hypotenuse of this triangle. Of course, is the side with the value 15, so we will put its value immediately into denominator of the function of sine. Now, if we remember correctly, for the sine we need a leg that doesn't make the angle alpha, and in this case it's the leg with a value of 9, and we will put the 9 into denominator. And there you go, we have that sine of alpha is equal to 9 over 15. Of course, we can simplify this even more, but we're not going to do that in this tutorial. Now, let's try to find the tangent of angle beta. For this, we will take a look at this green right triangle. Since the tangent is equal to the sine over cosine, we first need a leg that doesn't make the angle beta, and that is in this case the leg with a value of 5 plus 9, and that's 14, so we will put the 14 inside our numerator. And in the denominator we have to put the leg that makes the angle beta with hypotenuse. In this case it's the leg with a value of 8, and we will put the 8 inside the denominator. And there you go, the tangent of beta is 14 over 8. Now let's find the cosine of gamma. For this we will take a look at the yellow right triangle. For the cosine, if you remember, we need hypotenuse and the side that makes this wanted angle with the hypotenuse. So first, it's easy to see that hypotenuse has the value of 13 because it's the biggest side of this yellow triangle, so the 13 goes into denominator, and the side that makes our angle with the hypotenuse is a side with a value of 5, and we will put this one inside the numerator. And there you go guys, the cosine of gamma is equal to 5 over 13. As you can see, in this way you will be able to find any trigonometry function of any angle inside the right triangle in the function of its sides. Well, I hope you guys learned something new from this video, and if you did, please give it a like, it would mean a lot. And of course, if you have any question for me, or if you want me to cover some other mathematical topics, just put the comment down in the section below. Till next time, see you guys, take care.